All right.
Hi, Miss Ford.
So
Can't wait for this video.
So we are on practice test number 2. This is problem number 5. Here we go. We need to find the angle between these two vectors. Okay? So we just did this earlier. Who remembers the steps? There's some background information we have to put together. And then we're eventually going to second cosine. Remember, when you have to find the angle between two vectors, you're going to second cosine. But you need to know this fraction here that you're going to second cosine. So what are the pieces of that fraction? One is the dot product. So the dot product of these two vectors is first times first, second times second, -6. Right? Now, what's the second piece of it? What else do we need? We need the magnitudes. And we need both magnitudes. So the magnitude of the first one, I square, add them up and take the square root. That is not the answer, so remember, don't reduce that one, even though you're tempted to. And then you square.
12.
Is this the same? Are those the same numbers we had last time? They seem like it.
Yeah.
All right, anyway, I multiply those together, right? Once you get your two magnitudes, instead of having two separate radicals, make it one. So 26 times 25, or 26, yeah, times 20, 520. Now, you're going to second cosine a fraction. What is the fraction we're going to second cosine using that information? -6 over root 520. So we're going to second cosine the dot product divided by the magnitudes. Now, if by chance you get that turned around, you're going to get an error message. So that'll be your clue. You have it upside down. It has to be dot product over magnitude. So second cosine -6 divided by the square root of 520. 105.26 degrees. That is the angle between these two vectors. All right, so one more time. One more time. Find the dot product. Find the magnitudes. Multiply the magnitudes together. And then second cosine dot product over magnitudes. All right, remove the parameter and write one equation.
Substitution.
I heard Sophia say substitution.
I said it too.
You said it too. Thank you, Brett. So we're going to substitute. So looking at this bottom equation, it looks like y minus 5 equals t. So we'll take that y minus 5 and we'll plug it in right there. So x equals 2 minus 4 times y minus 5. Is that all right? And we'll clean it up. So x equals 2 minus 4y plus 20. So x equals -4y plus 22. Now that doesn't look like a normal slope-intercept equation. Normally it would be y equals and not x equals. If you want to change it to y equals, that's fine, but you don't have to. What was your job? To write an equation with no t's in it. And you got it. So you did what you were supposed to do. If you want to rearrange things, that's fine, but you don't have to. Okay. Now we're going to write the parametric equation. So we're going to come up with x equals and y equals. And the points are 2, -1, and 3, 4. So we need the slope, right? I'm gonna go ahead, because I remember it, I gotta remember it. My general format is going to be this every time. So it's gonna be xy equals parentheses plus t times parentheses. And in the first parentheses is going to go one of my points. I'm gonna use 3-4 this time.
Is that just because you said use the other one? You want to use
No, I like to use things that don't have negatives.
Oh, yeah, that makes sense.
Does it matter? No. So pick whatever point you want to pick. So the point always goes first. Always here goes the slope, right? So you may have already found the slope. I haven't, so I need to. So my slope will be 4 minus negative 1 over 3 minus 2. So I got a slope of 5 over 1. And here's where the mistake's going to be made if you're not paying attention. Slope is y over x. So when you write it here, it has to be 1 comma 5. Because y is 5, x is 1. Y is 5, x is 1. Then we write our answer in the answer blank. And on the answer blank, I include you in. I said x equals y equals. So you know there's another step. X equals 3 plus t. And y equals 4 plus 5t. All right, let's get the last one done. Some of you are watching the clock. Hurting my self-esteem.
I never looked at the clock once.
All right, we're going to find the components of the velocity vector for an airplane flying. No, stop right there. This means my setup is different. It means my setup is that. I draw my compass. I have a speed of 410 on a course of 218. This is 218. Right? And the speed is 410. And your job is to find the components. When you see those words, make an ordered pair to remind yourself that's what you're looking for. This is one of those where to find x and y, I'm going to need my sine and cosine, right? So I'm going to go ahead and make my triangle. Here's my x and my y. Okay, but now wait a minute. I need this angle right here. So just look at it. All the way to here is 218. You need to get this part?
This is just a reminder that all juniors should report to the auditorium for a mandatory meeting during class. Once again, all juniors, please report to the auditorium for a mandatory meeting.
Hang on, we're going to finish this. So what's this angle right here? 38. This angle right here is 38? No way. This is the one you want, and I'm going to do 270 minus 218. I think it's 52. I think the angle I want is 52. If you really think about it, you would know, okay, 38's this angle, and I'm okay with you figuring that out, but I'm not okay with you using 38 because it isn't in the butterfly bow tie. Any angle you use has to be in the butterfly bow tie, or it won't work. Okay? So, what are my equations? Cosine 52 equals x over 410. Sine 52 equals y over 410. Shh, come on, let's get it done so you can all run off to wherever you go. 410 cosine 52. 252.42. And 410, sign 52, 323.08. And before I close the page and walk out of the room, I'm gonna stop. Both negative, because I am in quadrant 3. All right, I will see you people tomorrow to wrap all this up. All last minute questions.